Hello student, welcome to today's session. So today we will be taking one important topic from the inorganic chemistry that pertains to silicates. And those of you who are preparing for IIT Advanced this year or even for the NEET examination, this particular topic, questions from this particular topic are very expected. So I am going to discuss along with you, as my style would be, 3-4 problems on the basis of silicate. One is for the IIT Advanced. This is a more than one choice question. Then this is a single integer type question, and two more, and this is again a single integer type of question, and one more single integer type of equation. So we will be discussing all of these questions once we have a little idea into the topic of silicates. What exactly do we mean by silicates? So silicates are the compounds in which these are the minerals or compounds in which silicon oxygen is the entities which are present in the compound in the form of silicon tetrahedron, SiO4 negative. This is the monomeric type of a thing which, when repeated again and again to form different patterns, that particular entity we call it as silicates. So as per the book of Hui, a very important inorganic book, it says that 3/4 of earth crust is containing different types of silicates, in which this moiety must be present, or it is present in the form of some repeating pattern. So for the simplicity, because every time we cannot make this tetrahedron while making the structures, for the simplicity, first let me show you. This is the tetrahedron which would have SiO4 negative. The corners are corners of the tetrahedron are containing, if I would draw just like this is a tetrahedron. These corners are having oxygen atoms into it, and in the center you have silicon, and this is being joined to all of these oxygen like this. So it is a beautiful structure which we call it as silicate, the simplest of all. Now the point is, just for the simplicity, because this is going to get repeated again and again to form different structures, make it a point, whatever is the type of structure, this tetrahedron type of a thing must be there. Silicon must be bonded to 4 atoms. Now the point here is, for the simplicity, if I would see this molecule from the top, if I see it, say this tetrahedron from the top, at the top I would find a oxygen, and below this oxygen is this silicon atom, which I am not able to see because I am seeing it from the top. So silicon is at the center, which is being eclipsed because of the presence of oxygen up onto it. And if I would see further, I would also see a equilateral triangular base at the bottom, so which I could see it like this, that there is a equilateral triangle at the bottom. So this is what I am referring to, and this equilateral triangle which is at the bottom is containing at the corners oxygen atoms, and these oxygen atoms, which I just have shown it to you, are bonded to this silicon by these bonds. Although it seems like this angle is 60 degree, this angle is 60 degree, which is not, because it's a 3D angle of the 109.5, which is a regular tetrahedron angle. Here it is looking like 60 degree. That is what you have to see it carefully, which way I am showing it. So let me repeat once again. I am seeing it from the top. From the top, if I would see this as oxygen, and below this there is a silicon which I would not be able to see. And one thing I should mark it here, this particular bond in this structure I am not able to show you, because this bond is below the oxygen, and from the top I am seeing it, and this bond I am not able to see. That is between this blue ball, and this is oxygen, and this silicon. This I am not able to show you. Other bonds I am able to show you. And secondly, which at times many people say, do it a mistake, these are not bonds. These are just, I am showing a tetrahedron structure. This is just to show that the oxygen are present at the corner of a tetrahedron. I think I made my point clear. What I am trying to say is, if as and where you would find this sort of a structure shown to you in any question, Make it a point, in actual this is tetrahedron. This is very important. Many of the times people start feeling it as a planar. It is a tetrahedron where silicon is at the center and the oxygens are at the corner of a tetrahedron. And you need to understand that how I have converted this particular structure from this. So make it a point, you have to have a good idea that this particular tetrahedron structure, these are exactly same. Only the point is the direction from which I am seeing it, that is different. Here I am seeing it from the top, that is why it is looking like this. So I think I made this point clear. Now the point is that as and when you come across, let's say SiO4 negative, if I just would take 2 moles of it and into this I just would add 2H positive, as per the stoichiometry, if you would see into it, Si2O7 minus 6 plus water. If you would just see the charge balancing, here you have 4 negative and 2, 4 to the 8 negative and 2 positive. So total charge on to the reactant side is minus 6, and that too on the product side is also minus 6. So what I actually have done, so if I would write it once again for you, SiO4 negative, O negative, O negative and O negative. Now this is being treated with H positive, in the sense that I am trying to explain it to you that how this entity is going to undergo polymerization. That is very important. So once I do this loss of water has happened. This first H positive joined with the O negative, then another H positive attacks it and take out water out of it, just like the organic chemistry. And then this oxygen attacks it. As a consequence, what you are able to get here is SiO negative, O negative, O negative, and you happen to get SiO bond. Now the point here is the one which is very important, this we got it as Si2O7 6 negative. Now the point is how I have polymerized, how I 2 units, this is called as pyrosilicate. How does it look in a 3-dimensional structure? That is very important to understand here. That how does it look in a 3-dimensional structure? Oh, sorry. So the point here is that this pyrosilicate, if I have to show it in the form of new structure which we have just drawn in the form of a triangular shape, so it would look like something like this. These are the oxygens and these are being joined like this, and this is the another one, oxygens, and at the center you have a silicon. At the center you have a silicon. So this silicon is at the center, and all of these are having a negative charge. All of these are having a negative charge. So what I did, I just brought 2H positive, took out this water out, and once this water gone out, this O negative attacks the silicon. As a consequence, what basically is being generated is this sort of a structure. This structure which I just have got is the structure which I was referring this as this entity. So make it a point, this is a perfect tetrahedron. Both the silicons are at tetrahedron, and in this structure also, both the silicons are in tetrahedron form. So these are the oxygens. These are the oxygens, and at the center here you have a silicon. This is silicon. This is silicon. Now the point here is the oxygen which got joined between silicon, two silicons. That is this is what I am saying. This particular oxygen. This oxygen would not be getting the negative charge. Now the negative charge are onto the oxygen atom which are joined to single silicon. That is very important to understand. And this we got it as Si2O7 6 negative. Another style of question which may come at exactly at this point is, which you might be aware of, that they simply would ask you Si2O7 X negative. Find the value of X. This is a very find the value of X. In upcoming questions, we will see some of the questions are having this sort of a thing in different domain. Find the value of X. So simple thing is that we have understood for sure that this particular species having, it is having two SiO4 negative tetrahedron, this is for sure, but they actually got joined through a common oxygen. As a result, when one oxygen goes out with 2H positive, the number of oxygen got decreased and the negative charge on two entities got decreased by a factor of 2. What I'm trying to say here, just try to understand with me. So this structure definitely must be formed from SiO4 negative, but these entities required are 2, isn't it? Now if I just would write it like this, that it is Si2O8 8 negative, just stay with me and try to understand a shortcut here. So basically our actual structure is having 7 oxygen. So that means the number of oxygen atoms got decreased by 1. One oxygen got decreased. Once you decrease one oxygen, because that water has gone out, that oxygen has gone out as water, the decrease in the charge would be of 2 units. The negative charge, this negative charge got decreased by, if I would write it here, negative charge got decreased by 2 units. So the negative charge which we get is 6 negative here. Did you get this point? I think I made my point clear. Let me repeat it once again. Here is one negative charge, this is one negative charge. Once this water gone out and this oxygen got joined here, so in this entity the negative charge got decreased by a factor of 2. Removal of one water while making Si bond, the decrease in charge is of twice. If the number of oxygen decreased in the form of water are 2, the negative charge got decreased by 4. This is very important, and in the upcoming questions you are able to understand it. So now let us see. Now the I would say it like this, that what I have just explained to you is a sort of pyrosilicate where two entities, silicate SiO4 negative units got joined to each other with the loss of water molecule. Now coming on to the question. Now in this question, what the fellow is asking, since it is a more than one choice question, we need to do it little patiently. A trimer of a silicate S, you are being given a silicate which is containing 4 units shown as under without negative charges. Okay. Identify the correct statement. Now this is the structure this is the silicate which is being given to you, but it is not showing any negative charges. That is you to see into. Now moving on to this options first, let me draw this structure first. Now what basically it is. So here you have a negative charge, negative. This oxygen, this also negative. The oxygen which is between the silicon, that is this one and this one, would not be containing any negative charge. So what is the formula here? The formula which I get here is Si3, because these are the 3 silicon which are being shown by green dots. Oxygen are how many? Oxygen are 10, 3 and 3 6 9 and 1 10. So 10, and the negative charge which you are able to see is 8 negative. This is the structure of this particular species. Am I right? Let us see into some of the options what they have given. S is this statement in itself is correct because they are asking for the correct statement. So first this statement is correct. As regard to the A option, charge on S can be balanced by 4 Ti 4 positive. So what formula did we get here? We got Si3O10 and how much had been the charge? 8 negative. This is the formula of the structure. So to balance this 8 negative, I shall be requiring in the form of titanium 4 positive, two titanium 4 positive are required, but they are writing it as 4. So this statement is a wrong one. So A option went wrong. Now coming on to the B option. What B option is suggesting? S on cyclization in the presence of acid gives me this entity. Let us check this out. Now if I have this particular species and it has to undergo cyclization. So how many silicon tetrahedrons do we have? 3. 1, One is this 1, 2, and 3. Now that 3 I can show it like this as well. Now this is very, very important. If you are able to understand this one, other problems are also similar to this one. So these are the oxygens. If I would draw it like this, just for the simplicity. So these are the oxygens, and this one is the silicon atom. So silicon atom I can show it with blue marker. So these are the silicon atoms. And where do you get the negative charges? The negative charges are present as, here you have negative. If I would change the color, this is negative, this is negative, this is negative, 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 negative. Sorry, this one is not. These are the negative one. Now if I would bring 2H positive here, and that will snatch out this water, okay, and this oxygen then would attack silicon. Is it okay? It is attacking silicon, not oxygen. This oxygen would attack silicon. As a consequence of the loss of water, what next structure do I get here? The next structure I would get a trimer of this type. Beautiful. So this is the beauty of the thing, that the chain, sort of a chain chain silicate underwent cyclization to give you a trimer type of a thing. Is it okay? So now what do we get here? Again, these are the silicon atoms. These are the silicon atoms that would remain still the 3. And you have taken out one oxygen out of this. So it has become 9. Now, if I just would write X negative here, it is very evident, because now it had been 8 and one oxygen went out. One oxygen when goes out takes out this negative charge, and this negative charge changes to the bond. So it get nullified. So basically, we would be getting here how much of charge? So the charge I would get is 6 negative. And in another way, which you always should remember, that this is negative, this is negative, 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 negative. Another thing which I was referring, that you should also remember to see into this entity. What is this entity? This entity is SiO3 2 negative, if you would see carefully. And this got repeated in a cyclic what I would say, cyclic trimer or cyclic silicate like this. Just feel it with me. So basically, you would also see, they may say it like this, that this would contain SiO3 2 negative, and such units are how many? 3. Or I would say that on cyclization, it happens to give me a polymerized form of this entity. Is it okay? This got repeated again and again. So as a matter of fact, Si3096 negative can be generated. So what had been the option? Yes, it is perfectly right. Now coming on to the D option, what the D option is saying? 2 anions of S on loss of 2 molecules of water in presence of acid may lead to this. Unlike the previous case, here he has cyclized only one S. Now he is saying if you have such S units are 2 in number, and 2 of them underwent loss of water, 2 moles of water got lost. Would it lead to a Si6O18? I think it do. Now what does it mean? If I have this trimer with me, which we just have drawn few minutes back, this trimer, and this one also, if you have the, what is this I have written? This is S, 2 units of S. And similarly, if I would draw you the corner ones only, so that we could save some time. So the corner ones are, okay, let me draw it, each of these. Okay, so what is the case here? You have oxygens here. These are the oxygen atoms, and along with oxygen, because I'm writing little fast, pictorially drawing would not be so good. So this would be negative, negative, and this also is negative, 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 and this is what entity? Si3O10 8 negative. Both of these units, negative, 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 negative. Now, if I would say that 2H positive comes and snatches out this water from here, then what would be the fate of the oxygen which is there? This negative would attack this one. So this would lead to cyclization as a matter of fact. And similarly, if I would bring 2H positive here and this would take out this oxygen, let's say for example, in that sense, this oxygen would attack this silicon. I'm referring here, you need to be little vigilant about. I'm referring that it is going to attack the silicon, which I'm marking it as blue dots. As a consequence of that, what would happen? Two water molecule went out, and you would get a hexamer, or on a hexagon, these tetrahedron would get attached. As a consequence, all of these, again it is cyclic as I said, and this would again contain a polymeric form of SiO3 2 negative, which are 6 in number now. As a consequence, what formula do I get from here? So this drawing you can do it at your place and can count it what I just have made. So here what I would get is Si6O 18 and 12 negative. So this would be the structure of this. If in case, let me repeat it again, what I just have said, Si3O10 8 negative, these are 2 in number, and to take out 2 oxygen atom I shall be requiring 4H positive. As a consequence, what I should I am thinking of making it like this, that it would get Si6O18 12 negative along with the loss of 2 moles of water. So make it a point, it is perfectly balanced. So 8 to the 16, 16 negative, 4 positive makes the reactant totality minus 12. Here also it is minus 12. So I think I made my point clear. It seems like D option is also perfectly right. So the answer to this particular question would seem like the options would be B, C, D are the correct one. Because here you need to be little vigilant that 2 moles of S loses 2 molecules of water may lead to, yes, it can lead to hexagon. Because why is it so? Or other way around, first you join two trimers you join from one point, then cyclize in the hexagon form. That also is the way to show that. That would happen in 2 steps. What I just spoke, that first you make this bond, this particular bond, first step, and then you make the second. So this way also you can lead to the formation of hexagon on which this 6 tetrahedrons are present. Beautiful question it had been. Okay, moving on to the next one. So here in this integer type question, what is the value of y minus x for a polymer of a silicate shown under without charges? So it's a simple one. Here nothing confusing should not be there. Simply you have to count the silicons. Silicons are 6 in number, I think so. So I just would mark it, or rather I would do it in the next page. So if you could see, here you have how many silicon atoms do we have with us? So 1, 2, 3, 4, 5 and 6. It seems like 6. Si is 6. O oxygens are how many? 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 are the oxygen atoms. Now simply you have to count the oxygen atoms. And one more thing, if you could see, whenever oxygen comes out to be in odd number, that means the terminals are not further joined. It is when the thing is in cyclic form, the number of oxygen atoms is even, and the charge would also be in the even negative. So the point is, here how many negative charges do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. In fact, this may be asked in the paper that if Si6O19 X negative, what is the value of X? If in case this is asked in this fashion in the paper, what shall then be the answer? In that sense, we will simply say that there are such tetrahedron which are 6 in number. So I can simply make a trick here, which I already have placed many times. There are many other ways as well. 24 and this is 24 negative. In actual, what is our structure? Our structure is demanding us 19 oxygen. So that means how much oxygen has been decreased? So oxygen atoms got decreased by unit of 6, unit of 5, unit of 5. 24 minus 19 would make 5. So that means the negative charge is double this number. So the negative charge which I would have to decrease, 10 unit negative charge would be decreased. So that means this would be minus, because this is 5, 24 minus 10 would be minus 14. So this is another way you may be asked in the paper. So the question had been simple. So what basically do we get here is Si6, O19 and Z is minus 14. So what shall be the answer? So X is 19 and X is 6 and Y is 19. So Y minus X then happens to come out to be 11. So the answer to this question would be 11. Moving on to the next one. So what is the next one? If the following chain of silicate make a cyclic ring of 8 of formula this, what is the value of X, Z and Y? A beautiful question, a very tricky question. So they have given you a tetrahedrons. How many tetrahedrons they have gave? I think it is 8 only, 7, 8. Yes, because they are writing 8. So they are saying make this silicate in a cyclic manner such that it would have 8 octamer. On a octagon, you have to make 8 such tetrahedrons, just like we have made for the trimer in the more than one choice question. So what basically we need to make here is, I just would want to, first you have to see into it what exactly it is. So it is Si8. How many are the oxygens? So oxygens are, if I would keep on writing the negative charges along with, these are the negatives 3. This would not have, these are the negatives. Am I right or not? These are the negative ones. So now let us see. So 3, 4, 6, 9, 12, 15, 18, 21, 24, 25. So this is 25. And now if I would ask you what is the value of X, you can do it simply like this. SiO44 negative. If another question is asked in this fashion, so it would be Si8 32 minus 32. Actual oxygen you want has to be 25. So you decreased how many oxygen atoms? So you decreased 7 oxygen atoms. 7 oxygen atoms you have decreased. I think I made my point clear. So 7 oxygen atoms when you are decreasing, so the negative charge would decrease by a factor of 14. Factor of 14. So this comes out to be minus 16. So that means it do make a minus 18. 18 and 20. Yes, 18 and now it would make 32. Yes, definitely. So X would be 18. So let us check this. Is it 18? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes, it is 18. I think I made my point clear. If you just have this formula in front of you and they would ask you the value of X, how do you get this? I just have said that out of I wanted 25 oxygen atoms, so I decreased it by 7. So the negative charge would decrease by the double amount, that is by minus 14. So 32 minus 14 is minus 18. So this makes a sense. So this particular formula which we just have wrote is Si8 oxygen 25 and negative charge has been minus 18. Now what they basically are asking us, they are asking us something like this, which we have already done few minutes back. So this is an octagon on which you can draw it like this, isn't it? This is an octagon. At present I haven't cyclized it. It is 1, 2, 3, 4, 5, 6, 7. I need to take one more. and this is the eighth one. This is the eighth one. Okay, this is the eighth one. So 1, 2, 3, 4, 5, 6, 7, 8. Now, what is the simple rule of the game? Rule of the game is you wanted to do the cyclization of these. So what I would take it here is this oxygen, and this oxygen. If I would show you the corner ones only. So 2H positive would take out this oxygen, and this negative charge oxygen would attack onto the silicon. As a result, a octamer would be generated. What basically I am doing is that if I would place 2H positive into it, one water would go out and I am left with SiO8 O24. One oxygen got decreased and negative charge would decrease by the twice amount. One oxygen decreased, so the negative would decrease by 2 unit of 2, so it becomes 16. So what basically do we have? If I just would show you like this, that what we have got, this is the structure which we are referring towards. So this is a octagon on which a tetrahedron form of this type has been generated, and this particular entity I am referring to it as SiO8 O24 minus 16. So what basically they are asking is the cyclic form. So cyclic form which I got is Si8 O24 minus 16. This I got. So now I have to place X and Y. So what is the value of X and Z? And Z is to be taken in the mod. So X is 8. So Z is your 16 and Y is your 24. So 8 plus 16 is 24 minus 24. So answer to this question is 0. The answer to this question would be 0. So you would have a value 0. Beautiful question again it had been. I hope you have understood that this cyclization, how did this cyclization has happened? How did this cyclization has happened? This type of cyclization we have already spoken on the trimer as well. We started with a trimer where you have understood it well in the first case. Here, if you could remember that we just have this oxygen attacks onto this, as a result this trimer is being generated. So this is the beauty of the thing which you always have to remember. Moving on to the last problem, which seems like easy. This is a very often asked question, and it can be asked in NEET or JEE Advanced, that you are supposed to find the value of Y here. So if I would break this structure, this calcium would always be 2 positive and Si6O17 X negative, and this is Y. OH is always having a negative charge of 1. So basically in this problem, this 12 positive, this is 12 positive, here it definitely would be minus 12. Then only it is a neutral silicate. Now we only have to identify the value of X. So you can simply adopt that formula, that how many silicons they have shown, 6. So you have 6 such tetrahedrons. So as a result, you should have this type of a thing. But in actual, how many oxygen do I have? 17 oxygens I have. 17 oxygen means that I went from this side to this side with the loss of the oxygen got decreased by, oxygen atoms got decreased by a factor of 7. So that means the negative charge must have decreased by 14. So negative charge by 14 units. So 24 minus 14 would be how much? What would be minus 10. This would be minus 10. So this means if this X value is minus 10, then let me write it on the next page. So what we have said, calcium 2 positive, Si6O17 minus 10 and YOH negative. So this happens to come out to be minus 10. So this Y definitely would be 2. So that whole of the anions, whatever are the number of anions, that must be having a charge of minus 12, because the cationic charge is of plus 12. So in this question, Y happens to come out to be The answer to this question, y is 2. So I hope you have enjoyed this particular session. This particular style of questions are quite important from NEET examination as well as for the IIT Advanced level. And the another style of question which you may get in the paper is on the basis of classification, that they would ask you pyrosilicate, chain silicate, amphiphol and so on. For that we have already made a video which you can refer to. I am putting up the description of that into the link of that onto the description. Thanks a lot. Have a nice day. Stay safe and take good care of yourself.